Okay, so 19.5 is actually not a section in the textbook. So we've basically covered everything that you need to know that exists in our textbook at this point. So from now on, it is all supplementary stuff that I'm including that you'll need to know for the next level. Okay.
Do you drop it?
Absolutely not.
Dropping it. That's what you need to know.
Good question. Fair game.
Are you serious or no? I can't.
No, there'll be tests.
They'll be tests. Okay.
For sure.
I know we don't have any more tests to take these guys. Yeah, I'm so excited about that.
Okay, so today's lesson I'm calling graphing the other three trig functions. Okay, so what do you think I mean by the other three trig functions? The reciprocal functions, right? So the reciprocal of sine is
Cosine.
Cosecant.
secant.
Is it just secant?
Cosecant.
Cosecant.
And the reciprocal of cosine is
Secant.
secant. And the reciprocal of tangent is cotangent. So those are the three that we're going to graph today.
I feel like cosecant should be with cosine and secant should be.
Well, you're not the math god, so you don't get to decide. Okay, so what I'm going to do is I'm going to start by drawing. I'm just going to draw this in blue because I feel like it's less dominating. Okay, so I'm going to show you how the reciprocal graphs are derived, sort of, like not a super intense look at it, but kind of like a minimal, like intense look. Okay, so if I start by graphing sine, okay, we have, let's see, if you draw 4 increments to the right, and go ahead and throw 4 increments to the left. The 4th increment would be our period, which in this case is, good, 2 pi. So half of 2 pi is pi, and then half of pi is pi over 2, and we can label that in the negative direction as well. Okay, and then I have to label my y-axis, Tori, and the y-axis comes from the amplitude. So the amplitude of this is...
Are you asking me?
Yeah, that was like a... Yeah.
The amplitude is the sine.
It's the sine?
It's 2.
So the correct answer is 1.
1. That was close.
Yeah, you guys were close.
So close.
So-
What is that cool symbol? Sorry, that was
Just so you know, that's the a value that's in front of the sign. It happens to be
Oh, yeah, that's
invisible.
what I meant. My bad. See, I was saying sine and like 1 times.
Yeah, you were exactly right. Almost. Good try.
What would an amplitude of sine be?
Okay, now where does yeah, it wouldn't be. You'd have to have a sign of something. Like it'd have to be the sign of 0 or the sign of pi 2. You'd have to have a number.
Oh, okay.
Anyways, don't go there. Where does sine usually start? 0, 0, right? So it has this trend where it goes 0, then it goes to the max, then it crosses the midline, then it goes to a minimum, and then comes back to the midline. And if we kind of continue that pattern in the left direction, it would look like that, right? So if you connect this dot, you draw a perfect little wave that we know continues on forever. Okay, now, check this out. So since we're talking about the reciprocals, the reciprocal of sine would be 1 over sine, right? Which by definition is the cosecant function. Okay, so what becomes really important in this scenario, is that more important than me?
I don't know. It seems like a business call. I'm kind of scared. Don't answer it.
It's probably,
A scam. Don't
yeah,
answer it.
scam.
Answer it so it's not.
It's a 406. Yeah.
You're a home dog. Just tell
They'll
them
leave a
that.
message if it's
Yeah, we're in the middle of
Come
math.
on.
I'm really trying to focus
Priorities,
on math.
it'll be
It's for
fine.
NHS.
Anyways,
You have to
so they know you're in school. It's for if it's for NHS. Then good students would not answer their phone. That was a test. Just
I
saying.
mean, it might be statute. You only answer my phone.
You're out of NHS because
Yeah.
There's Snapchat.
Okay, so as I was saying, the points that become very important. Okay, so the places where the sine functions cross the x-axis. What is the y value at those places? 0. Okay, so what I'm saying is, if we have 1 over 0. What is going on in that scenario?
That's like not.
Thou
Right,
shalt
it's not
divide
possible.
by
The math
zero.
god said, thou shalt not divide by 0. So graphically, what's happening?
Nothing.
It's finding zeros.
Ooh, okay, I hear holes, I hear asymptotes. Okay, what's going to happen is there's going to be vertical asymptotes.
Everywhere.
Okay, so do you see all those places where the sine function crosses the x-axis? On our cosecant functions, those are the places where we have vertical asymptotes. Okay, so we are going to have a vertical asymptote at x equals 0. We are going to have another one at x equals pi. And then another one at 2 pi. And you can see that in the negative direction, there's one at negative pi and negative 2 pi. So, can anybody give me like an observation about maybe the distance between the vertical asymptotes?
Pi apart.
They're pi apart. Okay, so let's relate that to a period because that's where we initially drew our sine function, right? So if our period happens to be 2 pi, how can we make a statement between the vertical asymptotes and the periods? It's exactly half of them. Good. Okay, so I would probably write this down somewhere and say my vertical asymptotes occur every, apart, whatever you want to say, every period over 2 units. Okay, so the distance between them is the period divided by 2. Okay. The other thing, yep, always. The other thing that is going to become important is those amplitude, those maxes and mins. Okay, now I'm going to draw this line it's kind of like a nullity line. I'm making this kind of up. It just helps you to draw cosecant functions. And I'm going to call this, or these two lines, amplitude lines. That's not like an actual thing, that's like my word for it. Okay, do you see why I'm calling them the amplitude lines?
Yeah, because they don't go in this.
Yeah, they're like at the amplitude. Okay. All right, so anybody want to take a stab at what this function looks like?
I do.
Oh, what does it look like?
Like that.
That's not your usual.
What is Zupu?
Zupu? There you go. It looks, yeah.
I feel like that sound doesn't work.
Oh, this one is not the same as the other
No, I
functions
just feel like
you've
it's
drawn?
different. Like it's just because it's more like
Oh,
that.
wow, okay.
Yeah.
All right. So if you were going to describe a cosecant function, how would you describe it? Just those green things.
Zupu.
What do those look like to you? They look like parabolas. Okay? So the cosecant function is literally parabolas alternating from upwards to downwards, upwards, downwards, upwards, downwards, separated by those amplitude lines. Okay, so you might call this like a parabolic party.
No. Not.
Oh,
I'll think of something.
all right. Well, whatever. Okay, let's talk about the next one. So let's use cosine to figure out secant. Okay, so really quickly I'm going to draw a pretty little graph and do 4 increments to the right and 4 increments to the left. You're going to start to notice that I have this little trend about how I draw trig functions. I really like 4 increments because it makes life really easy. Anybody want to tell me what the length of that 4th increment is?
2 pi.
Where did you get that from?
I
That's
guess.
what it is. That's what the last one was.
Oh, it happens to be the period. So your fourth increment is always the distance of your period
In cosine. Right.
on secant and cosecant. And sine and cosine if you want to go there too. So yeah. Alright, so half of 2 pi is pi, and half of pi is pi over 2, and we can do that in the negative direction. Okay. And then I'm going to do my y-axis, and what's going to become important? My amplitude. So I need to go up 1, I need to go down 1. So if I draw the cosine function, that one starts where? At the amplitude. So this one's going to start at 1, then cross the midline, hit a min, and then cross the midline, come back to a max. And if I follow the pattern in the negative direction, I get something like this. Okay, so if I think about the reciprocal of the cosine, so 1 over the cosine, which is what, by the way? Our secant function. Where am I going to have vertical asymptotes? Okay, so what I'm looking for is where is the cosine equal to 0?
Pi 2.
Good.
Oh,
At pi over 2.
wow, a fourth
Is that
of
3
pi.
over 4 pi?
No, a fourth
3
of the
pi over 2.
period.
Whoa.
Pi over 4 is.
So x at pi over 2. This one is 3 pi over 2. I have one at negative pi over 2. And another one at negative 3 pi over 2. Everybody okay with where we found those?
Yeah.
Okay. So I'm also going to draw my amplitude lines. Okay, so that's where my sine or cosine function maxes out or mins out. Okay. So anybody want to take a stab at what the secant function looks like? Go ahead, say it louder. I can't hear you very well.
Like it's like sun, like cosecant,
Mm-hmm.
but instead of like being half the period, it's like it's over.
Like which direction? Whoops.
I look at this.
Yeah, you're right.
Like I see it in my head.
Oh, it's gonna mess up my graph, but it's okay.
Okay, so it just shifted to the right, or you could technically argue to the left. One of the two, right? Oh my gosh, I drew that in the wrong spot. I can't see my tablet right now. How about this one? There we go. So all of those maxes and mins are going to touch the tops or the bottoms of the parabolas. Okay, so note to self, cosecant and secant functions look like each other. They're parabolas, right? Okay, one is just shifted a little bit to the left, or technically to the right, or whatever you want to say. Okay, what else do we need? That looks pretty good. Okay, can I move on to the next one? Check. Scrolling down. Okay, last one is our cotangent. So we're going to use the tangent function to figure this one out. So I'm going to draw 4 increments. Okay, and I'm going to do, my fourth one is going to be 2 pi.
Josh Schmitty.
That was the point.
Josh Schmitty.
Apparently you needed some blessings.
That wasn't funny.
Is that one supposed to be pi over 4?
Fun.
However, oh, what am I doing?
I don't know.
No, I don't know. My bad. Good catch there,
Good job, Garrett.
Garrett.
So it's just pi.
I don't know. I was very distracted by some people in the back.
By the blessings.
Thank you. Yeah.
Blessings on blessings on blessings.
Okay. All right. So, do you remember where the tangent function has its vertical asymptotes?
Yes, every pi.
Where's the first one at?
Pi.
So nobody remembers?
That one.
That's what
So I'll tell you, if you forgot, they are at pi over 2 and negative pi over 2.
You could have just said that wrong. That was very rude.
It was?
I'm just kidding.
So you might say, oh wait, why am I writing these down? Sorry, don't write them down. Okay, so tangent function, I'm going to draw this really lightly. Usually looks like a John Travolta, right?
Correct.
Going right through the center of the origin.
Oh, that's a cool color.
Okay. All right, so if we think about the reciprocal, which is the cotangent, where is my first vertical asymptote for the cotangent going to be? Okay, so I'm asking you, where is the tangent equal to 0? At 0, good. So, hold on, I kind of drew these, I shouldn't have drawn these like boldly red. My bad, guys. I'm going over them in gray to blot them out a little. Okay, so for my cotangent, my first one is going to be at 0. So I have vertical asymptotes at x equals 0. Where else does it cross the x-axis? Pi. Okay, so you have one at pi. You kept going, you'd have one at 2 pi. You'd have one at negative pi. And if you really wanted to keep going, also negative 2 pi. So, did anybody notice something that I did here? I was kind of hoping that somebody would catch it, but did you notice that when I labeled my x-axis, I just went straight to 2 pi? And I didn't like say, what's the period? Did anybody notice that?
If there's nothing in front.
Because what's the period of a tangent? Pi. Okay. So the period of a tangent is pi. But when I draw it, my fourth increment is always going to be 2 times your period. Okay, so I'd probably write that down and say my fourth increment is always going to be 2 times the period. Okay, and that's for tangents and cotangents. Okay, if you keep that 4 increment scenario, everything will stay the same. Okay, so how far apart are my asymptotes? Okay, tell me in terms of the period.
What was the question?
How far away are my vertical asymptotes in terms of my period?
Pi divided by 2.
They're exactly a distance of 1 period apart. Okay, so my vertical asymptotes are a distance of 1 period. Okay, so I still have to draw my cotangent function. Does anybody want to make a guess as to what the cotangent function looks like?
They make X's from the tops.
Yeah, on the top of a tangent it does. Okay, so a cotangent function is a John Travolta, but with his left arm up.
Oh. Yeah, that's lame. I don't like this one.
Tori, this is the second time you're leaving class.
I don't like this one as much. This isn't as fun as the other two.
Yeah, it's not, that's true. Okay, so draw the green function. Make sure you're drawing the left arm up. Okay, but cotangent is just a John Travolta dance party. That looks really sloppy from here.
I mean, you should see my notebook.
So make sure you give yourself like nice notes, or maybe even like get rid of, like, erase the tangent function so you can see just the cotangent.
Yeah.
So like, I'm just gonna copy and paste a picture. But I can't draw.
It does.
A picture?
I can't draw either.
Okay, you guys ready for an example?
No.
I'm gonna make up an example. Number 1, let's do something simple. Let's do y equals 3 times the cosecant of 2x. So let's just do one that doesn't have any kind of shifting going on. And I'm going to show you exactly how I want you guys to do all this. Nice little system to our madness. Okay, so first thing we always do is list our stuff. Okay, so our amplitude, our b, our period, our shifts. So tell me what our amplitude is.
3. B 1/2. P.
Whoa, okay. B is 1/2. Everybody okay with 1/2? So period.
Pi.
Right, because it's 2 pi times a half, right? So pi. Okay, tell me my shifts.
None.
Yeah, none. Okay, so now draw your little coordinate grid.
Draw.
Okay, so by the way, I'm not supplying your grids today. You're drawing your own.
Oh, bullocks.
Trust me, that's a good thing.
That's a good thing.
It is way easier to do your own grid. Okay, so you're going to draw 4 perfectly equal increments to the right, perfectly equal, and 4 to the left. Okay, so what is the distance of my 4th increment for this one?
2 pi. Pi.
Pi. Okay, so the 4th increment is always the distance of your
See,
period.
I got it. Just...
Okay, so from there, I'm just going to make sure I get to the, excuse me, the first one. So what's half of pi? And what's half of pi over 2? Okay, I'll label that in the negative direction. Okay. Alright, so from here, I'm just going to start with my vertical asymptotes. Okay. So before I draw this, I want to go back up and look at my 3 parent functions. And I'm going to show you a little trick that I use. Okay. So there's 2 functions that start with the letter C. Which are the 2 functions? Cosecant and cotangent, right? Okay, so the 2 functions that start with the letter C, their first vertical asymptote is at 0. See what I did with my hand there? That's literally how I remember that.
Hold on, dude.
C makes a 0. That's where that's where the first vertical asymptote
Oh, you
is.
just look at it.
Very simple. Okay. So,
That's amazing.
since my first one is a cosecant, where is my first vertical asymptote? At 0. Okay, so I am expecting you to label your vertical asymptotes and tell me where they exist. Okay, so we're going to have vertical asymptotes at 0. Where's the next one going to be? Pi over 2. So you can think of this one of 2 ways. You can say they're always going to be a distance of my period divided by 2. Or if you're me, you start to figure out nice little tricks and you just say it's always going to be every 2 increments. So 2 increments from 0 happens to be at pi over 2, so I'm going to list that. And if I go further, the next one would be at pi. And I can go in the negative direction, throw down 1 at negative pi over 2, and 1 at negative pi. Okay, so now on my y-axis, I need to list my amplitude lines. So where are my amplitude lines going to be? 3 and negative 3. So there's 3, and there's negative 3. So make sure you label them. Don't just throw down lines because I don't know how high you're going. So eventually, with this trick, they all look the same. Okay, so now that I have all my little bounds for my function, I can just draw my cosecant. So what does it look like? Where is my first parabola going to go?
Top right.
Top right. Okay, so the first one is right here. So this, remember, that was my first vertical asymptote right at 0. Your first parabola is always just to the right of it. Okay, and then you alternate up, down, up, down. You can do as many parabolas as you can fit on there. Or more if you feel like it. Voila. Okay, we're not going to list any points or anything like that. We could go as far as listing those mins and max points, but I'm just going to be okay with this information for now. Okay. Awesome? Okay, let's do one with a shift and then we'll call it good. Number 2. Let's see. Ooh, I'm going to really trick you. Negative 3. Secant. Oops, that was not a secant. Secant of, let's go with 1/2 x plus pi over 2 plus 1.
How's this supposed to? Oh.
Well, you'll have to wait for it.
I know.
You already know it. Okay, what's my amplitude? 3. Now, if you said negative 3, I would be okay with that. Just remember, what does the negative do to the function? Flips it upside down. So the idea is that, like, kind of reflects it over the midline. Okay. We'll talk about it. Yeah, the midline is 1.
2.
Okay, my b value is 2. What's my period? Times 2. 4 pi.
Guys, remember tangents.
Tangent's the only one, yeah. Okay, what else? We need shifts. Okay, what are my 2 shifts? Okay, good. Left pi over 2 and up 1. Okay. Awesome. Alright, so draw your nice little coordinate grid with 4 equal increments to the right and to the left. Okay, so tell me, what is the 4th increment going to be? 4 pi, good. So we got 1 at 4 pi, and then I need to label all the way to my first so I know how far 1 increment is. So what's half of 4 pi?
2 pi.
And half of 2 pi?
Pi.
Pi. So we're going by pi's. Yep. If you want to label that 3rd one, absolutely. Alright, let's do the vertical asymptote. You ready?
Go below.
Okay. Now the first thing I have to think about is where the first vertical asymptote exists with secant. Okay, so if you go back to our nice little parent functions, where is the first vertical asymptote? At pi over 2, right? Okay, now I will tell you that the first vertical asymptote on a secant will always start at the first increment. Okay, so I'd probably write this down and say vertical asymptote always, or first one, always starts at first increment. You might not want to abbreviate if you can't remember what that means 5 days from now.
Incorporated.
increasing. Who knows? Okay, first increment. So, if I'm working on my secant, where is my first vertical asymptote start before I take my shift? At pi. So now if I take that and move it to the left, pi over 2,
Oh, that's really interesting.
where is my first vertical asymptote?
Wow.
Pi over 2, good. Okay, so that just happens to be exactly halfway between my first increment. Okay, so make sure you list vertical asymptote is at pi over 2. Okay, now we need another one. Where is the next one to the right gonna land? And how would I figure it out? It's gonna be right there. I know it's two units away, right? It's a distance of how far?
5 pi. No.
Okay, it's a distance of 2 pi. Remember that it's a distance of half of your period. Okay, so if my period is 4 pi, our vertical asymptotes are going to be a distance of 2 pi. So if I have pi over 2 and I add 2 pi, where do I land? 5 pi over 2? Does anybody else agree with that? Okay. Okay, what about the one to the left? If I go in my negative direction. Thanks, Luke. So that one would land at negative 3 pi over 2. Is everybody okay with where I'm getting these numbers?
Yes.
Okay. If you're struggling, let me know because I can explain it. You're okay? Okay. Okay, let's talk about the y part. Okay, so first of all, what's my amplitude? 3, right? My amplitude is 3, but I have a shift. Okay, so let's talk about this upper, what did I call this again? Amplitude line, right? So if I'm up at 3, but I have a shift of up 1, where is that amplitude line going to land? At 4. So we're going to have 1 at 4, so draw 4 increments, and make sure you label that 4 so I know exactly how far you're saying that goes. Okay, and if the other one was at negative 3, but I moved that up 1, where is that one going to land? Negative 2, good. So those are my 2 amplitude lines. Okay, so now I have my bounds. How is this going to look? Okay, I have to draw the secant function. So it usually starts up.
Down left.
But, right, good. Okay, so do you see where your first vertical asymptote is? Okay, I start it because I always want to know where that first one is. Okay, you usually start with a positive parabola just to the right of it. Okay, well if my function has been flipped over the x-axis, this parabola is going to go upside down and exist underneath my lower amplitude line. Okay, and then they just alternate just like they did before. Okay, so it's going to look like that. Does that make sense? Sort of, kind of, maybe not.
Makes sense to me, yes.
It's really cold. Oh, you guys can move. Here, I have a chair right here. You prefer the cold chair than sitting next to me? I'm done talking. Okay, is everybody okay then? Okay, so the worksheet that I made for you was really bad. So I had to change the assignment on the fly here. So this is what you're going to do. On a clean sheet of paper, you're going to do these 6 problems. Okay, so